Okay, now I'm going to try to demonstrate this. Obviously, you might not be able to see the BB. There it is, okay? It dropped from here, bounced about here. Probably at least a 90% coefficient of restitution. Now what I'm going to do, I'm going to try to do this. I don't know if this is feasible.
You need someone to give you a hand?
It might be feasible if I could hang on to the BB. Okay? So, I'm going to be proud of myself if this actually works. Okay? Now you hopefully heard that. We got several collisions there, probably 10 collisions or so, as the tiles approached each other. So now we have an interesting problem. Now let's have a tile and a tabletop in a high coefficient of restitution. Okay? You can look up coefficient of restitution, you should. Very simple definition. That you'll understand just fine in terms of watching this BB, okay? So we got a BB here. Then we drop the BB, it comes down here, comes back up, and the tile is approaching the BB, okay? So the tile gets closer, the BB comes up and hits the tile. The tile's moving, which speeds up the BB. Okay, and every time it collides, it speeds up the BB. And of course, the BB gets faster, the tile gets closer, so the BB bounces back and forth more and more frequently. Okay? So this tile approaches here, and you know, you have positions of the tile, you have the BB here moving faster, and then you have the BB here moving faster, and more collisions, and that picture doesn't really show you anything, but you get the idea. Okay? BB speeds up with every collision. A shorter distance between collisions. Lots of kinetic energy gain. I could pose the problem if this thing comes down at equal, you know, at a uniform speed. How far does a BB travel? Now we could assume 100% coefficient of restitution, coefficient of 1, right? So the BB never loses any speed on collision. Or we could assume a coefficient of restitution of 0.9, which is more realistic for the BB. We could even ask ourselves, how does the coefficient of restitution affect the results of our model? And we could figure out the average force the BB exerts on the tabletop or on the tile. That'd be an interesting problem, which I will probably pose. Okay?